Hello, and in this video we're going to discuss different measures of position, where the first one being a quartile. So to begin, let us define what a quartile is. Quartiles of a data set partition or breaks apart the data into 4 equally sized in terms of number of data points sets, including the boundaries. So, as an example, suppose I have the particular number of weights for a set of people, and those weights are equal to 76, 78, 79, 79, 82, 83, 85, and 87. Firstly, 76 is equal to the minimum of this data set, and 87 is the maximum of this data set. Also, you may be able to determine on your own that this number of data points in this set is even. Therefore, the median is going to be the average of these middle two values. So when you add 79 and 82 together and then divide by 2, you're going to get this is equal to 80.5. So this is the median. So what does the median, min, and max do for a data set? So let us sketch that out. So 76 is here, 80.5 is here, and 87 is going to be here. So, including the boundaries, 50% of the data points are going to be here, and 50% of the data points are going to be here. Therefore, if we want to break this up into quarters, then that means we need to find a point that pretty much breaks these halves in half. So according to this data set, the left-hand side of this set is going to be 76, 78, 79, and 79. The right-hand side of this set is going to be 82, 83, 85, and 87. So I can find the median of these two sets. So this is going to be 78.5, and this is going to be 84. So this is going to be the median of the left, and this is going to be the median of the right. So if I map this out again, so I'm going to have the minimum here, I'm going to have 78.5 here, I'm going to have 80.5 here, I'm going to have 84 here, and I'm going to have 87. So if I group these data points here, I'm going to have 76, 78, 79, 79, 82, 83, 85, and 87. Notice that these 5 numbers, 76, 78.5, 80.5, 84, and 87, partition the data set S into 4 equally sized sizes. So these are what we call quartiles. So we're going to denote the first one as Q0, the next is Q1, Q2, Q3, and finally Q4. So these are the quartiles. So Q0 is always equal to the minimum of the data set. Q4 is always equal to the maximum of the data set. Q2 is always equal to the median of the data set. And Q1 is going to the median of the left side of the data set, and Q3 is always going to be equal to the median of the right side of our data set. Let us demonstrate with another example. Suppose we give a test and we record the test scores of that test. Now let's assume those test scores are equal to 76, 93, 69, 87, 97, 85, 89, 98, and 74. One of the important things to note about how to calculate the min, max, median, and the quartiles is that the set must be ordered from least to greatest. So we can restructure the set from least to greatest as so. So the least value is going to be 69, then followed by 74, 76, 85, 87, 89, 93, 97, and 98. So we can clearly identify Q0. So Q0 is always going to be the minimum, and Q4 is always going to be the maximum. So we have 4 data points on the left and 4 data points on the right of 87. So that means 87 is going to be the median of this data set, which is Q2. So to break this data value into more equally sized pieces, I can cut in between 69 and 74, cut in between 89 and 93, and that is going to be where Q1 and Q3 are going to be located. So notice that 87 belongs both in this quarter and this quarter as well, which is why in the previous definition we included the boundaries to be equal to the partitions. So Q1 is going to be the average of 74 and 76, which is going to be 75, and Q3 is going to be the average of 89 and 93, which is going to come out to 91. So let us make sure that everything is working correctly. So if I have everything done correctly, then I should have all of these values partitioned equally beyond these 5 numbers. So Q0 is going to be 69, Q4 is going to be 98, Q2 is going to be 87. So 76 is going to be here, 85 is going to be here, 74 is going to be here, and on the right hand side we have 89, we have 91, 89, 93, and 97. So are these equally spaced data sets? The answer is yes, but of course in the untraditional definition of evenly sized. So notice there are 5 numbers on the left and there are 5 numbers on the right. So if you divide that in half, that means you have 2.5 data elements on the left and 2.5 data elements on the right. But you can't have a half of a data element, so there's no real sense in defining that there must be an equally sized amount of numbers in each of these little quarters. So therefore, as you see, there's 4 numbers on the left of our median and 4 numbers on the right of our median, so our data sets are going to be equally distributed. And also note that there's going to be 2 values here, 3 values here, 2 values here, and 3 values here as well. So overall, everything seems to be balanced, but that's pretty much how we find the quartiles, where Q0 is equal to the minimum, Q4 is equal to the maximum, Q2 is equal to the median, Q1 is equal to the median of the left, and Q3 is equal to the median of the right. Overall, notice we have 1, 2, 3, 4, 5, 6, 7, 8, 9 different elements here. So when you have 9 different elements here, it's not always certain that they're going to fall directly on the boundaries. Yes, the median, the minimum, and the maximum are always going to be in that set since it's going to be odd, but when you partition on the left and the right, then it's not necessarily going to be there. Whereas for an even data set, like in the previous example, notice that the minimum and the maximum are not necessarily, or well, are always in the data set, whereas all the other quartiles possibly are not in there because you're dividing by 2 usually. So at least for the odd number of data points, we have 3 points that are guaranteed to be in the data set in terms of the quartiles, whereas for the even number of data sets, we're only guaranteed at least 2 values. And that's pretty much how to calculate the quartiles of a data set.